So to start to figure out where the beginning of the second bend is going to go, we're going to need to note a couple measurements and use some math here. Now we measured the start of the first bend from the floor, which is the 0 point of our y-axis, so to speak, is 32 and 7/8, or no, 5/8 of an inch right there. So 32.625 inches. Okay. We know that the start of the first bend is 18 inches from center, and we know that from the center to the complete outside of the main hoop is 28.25 or 28.25 inches. We just took our 56.5, divided it by 2 since we're measuring from the center out. Subtract our 18 inches from the start of the first bend to get this leg of the triangle. Now, when we're trying to figure out this length, we're basically going to use trigonometry to figure out that length and then add it to the 18 inches so that we can get the start of the second bend. So, back to what we were saying, one of the legs of the triangle right here, 18 inches minus the 28.25 is going to give us 10.25. And likewise, for the other leg of the triangle, we do our 40 inches, which was our entire height that we were trying to fit in. We do 40 inches minus the 32.625 to get 7.375 inches. Now, we go ahead and use what's called Pythagorean's theorem. Probably remember this from school, a squared plus b squared equals c squared. Go ahead and get that calculation all figured out. And take the square root of the sum of both of those squares is going to give us the length of this leg right here to the start of the first bend, which is going to be about 12.625 inches, which is 12 5/8 of an inch. So when we go to actually transfer this onto the tubing, we're going to add 12 5/8 of an inch to the 18 inches we have from the center line of that tubing, and that's going to be the start of the second bend. Now there's one more thing we're going to go over before we actually start taking measurements, and that is going to be the amount of material that is used in every degree of bend. So if you look on the left here, we have basically a figure of our bend. We're going to assume it's a 90-degree bend, and we're going to calculate how much material is actually stretched from the beginning to the end of this bend, this 90-degree bend. Now we know the center line radius of our die is 4.5 inches. And we also know that the circumference of a circle, dictated by C, is 2 pi times the radius. Our center line radius is 4.5 inches. Okay? So then we can also say that our circumference of the entire circle is going to be 2 times 4.5 times pi. Okay? Since we're only doing a 90-degree bend right here, we're only going to take up a quarter of that 360-degree bend that makes an entire circle. So what we can also do is just divide this whole schmear by 4, and we're going to get the actual distance from here to here in material along the center line of this bend. Now you can go ahead and use your phone calculator or whatever calculator you have, or just do it in your head, but basically we're going to end up with about 7.065 inches per 90 degrees. So that's how much material is actually going to be in this bend. Now we can also figure this out per degree that we're going to bend, and that's going to be kind of important later on when we go to calculate the start of bends past a prior bend. So we can go ahead and divide this whole thing by 90, and you're going to get about 0.0785 inches per degree bend. Alright, so to calculate the total length of material we're going to need for the main hoop, all we're going to do is add up the lengths that we have here for one side of the main hoop, multiply it by 2, and that's going to give us the total length of material we're going to need. Okay, so after we figured out the total length of the material need for the main hoop, we went ahead and cut it to that length. Next steps are to actually transfer the measurements that we made in the car onto the tubing. So we find the exact center line on the tubing, and we had 18 inches from center line to start a first bend. So we go ahead and measure 18 inches from the center line, Make a mark to the first bend, which right now is lined up in the die right there. Now at this point is when we take into account our tolerance. So you measure 18 inches from center line to the start of the first bend, take off your 1/4 inch tolerance, and make that mark. That's where we're going to start the first bend, and that's going to bring it in 1/4 inch off of the B pillar so that we can actually compress the main hoop to be able to weld it all the way around when we put door bars in there. So let's go ahead and get the bending and get this main hoop all bent up. Alrighty guys, so after we bent it all up, got her fit in, it all fits pretty decent. You see how it comes off the B pillar about 1/4 inch right there? That's from that tolerance. One thing we did do is this is actually the second main hoop I had to make for this. I messed up the first measurement for the second bend. It ended up putting it way too far down here. So we subtracted off the difference and I rebent it. Those things kind of happen when you're doing this by hand. We try and avoid it, but sometimes it's inevitable. I've never done a Z chassis before. Now we got it all fit up good. Right now, it's sitting on the floor. This is actually going to get rocker boxes put in, so we're going to cut off the difference between the bottom of the floor to the top of the frame rail, which is about 5 inches. We'll make up that difference right there, cut it off, make our rocker boxes, and that will also give us the opportunity to drop this roll cage down so that I can weld the backstays around the top as well as the A-pillar bar. And the next video, I'm going to show you guys how we make the bar line perfectly up with all these compound angles.